Here's number 3, the alternative method when you let x equal e to the t, and then compute your derivative and your second derivative, just like in question number 2. This is question number 3. When you make these substitutions, notice that this 1 over x squared will cancel out with the x squared. And so your second derivative term is just going to be the second derivative minus the first derivative. So I'm going to get second derivative minus first derivative when I substitute into this first term. And then I get plus 3 times x times my first derivative. And notice that the first derivative has a 1 over x that will cancel out with this x. And so I just get 3 times my first derivative term. So this would be 3 times, I'm going to call it y prime. In this case, y prime is not dy dx, but is dy dt. We're writing this in terms of t. And then minus 8y is equal to, and here when we make our substitutions, notice that if x is equal to e to the t, then taking the natural log of both sides here, the natural log of x is going to be equal to the natural log of e to the t power. And this natural log and the exponential function cancel out to give you just a t. So this natural log of x to the third power is also written as natural log of x to the third power. Here this natural log of x is just t. So this gives you t to the third power. And again, natural log of x is t. So this is just t also. Now, here you can combine your y derivative terms. These are like terms, so they can be combined to give you the second derivative plus 2 times the first derivative minus 8y is equal to t to the third minus t. And now we have a second order linear ODE with constant coefficients, and we can solve by letting y equal e to the mt, and to find our characteristic solution, substituting in and then factoring out e to the mt from each term, you'll be left with what's called the characteristic equation, m squared plus 2m minus 8 equals 0. M squared plus 2m minus 8 factors into m plus 4 times m minus 2. And then setting your factors equal to 0 and solving, you'll get m is equal to negative 4 and m is equal to 2. So your characteristic solution is c1 e to the negative 4t plus c2 e to the 2t. Okay. Now what we want to do is we want to find the particular solution. We want to find the particular solution that will cancel out this t to the third minus t. And because that's polynomial in form, we can use the method of undetermined coefficients. And we need to let our particular function be a third degree term. And so we need all those terms lower than a third degree, going down to the constant term. And we'll substitute into this differential equation and then solve for a, b, c, and d. So if yp is a t to the third plus bt squared plus ct plus d, then yp prime is going to be 3a t squared plus 2bt plus c, and yp double prime is going to be 6at plus 2b. Should be a 6. And substituting into my differential equation, I'm going to substitute in for the second derivative plus 2 times the first derivative minus 8 times my particular function equals t to the third minus t. I'm going to get my second derivative is 6at plus 2b plus 2 times my first derivative, 3at squared plus 2bt plus c, and then minus 8 times my original function, at to the third plus bt squared plus ct plus d. I'm going to combine those like terms. Starting with my highest degree term, notice I only have 1/3 degree term, and this is multiplied by negative 8. So I get negative 8at to the third plus, next for my t squared terms, I've got this t squared term, and this is actually 6. 2 times 3 gives me 6at squared. I'll just put a 6a in parentheses, and here I have a t squared term, and that's multiplied by negative 8. So I get minus 8b. Those are my t squared terms. And then my t terms, here I have a 6a. Here 2b multiplied by 2 gives me a 4b. And then c multiplied by negative 8 gives me negative 8c. Those are my t terms. And then my constant terms are 2b this is 2c minus 8d. Okay, and this should be equal to t to the third minus t. So using the method of undetermined coefficients, we want to equate the coefficients for like terms. So we want to look at these t to the third terms, and we want to set the coefficients equal to each other. So for our t to the third terms, we're going to get negative 8a is equal to 1, and that tells us that a is equal to negative 1/8. On the t squared terms, notice that I have a t squared term here in terms of a and b, but I don't have a t squared term to match it up with. That tells me that 6a minus 8b is equal to 0. And here I can bring my b term over to the right side so that I get 6a is equal to 8b. And let me divide by 8 so that I get b is equal to, and when I reduce this I get 3/4. I get b is equal to 3/4 of a, where a is negative 1/8. So I get 3/4 times negative 1/8 gives me negative 3/32. That's b. Okay, equating my t coefficients, I get 6a plus 4b minus 8c. 6a plus 4b minus 8c, and that should be equal to negative 1. So I know the value for a and the value for b, and so let me solve for c by bringing my c term over to the right side, and I'll bring that 1 over to the left side. so that I get 8c, that's actually on the right side, and on the left side I'll get 6a plus 4b, 6a plus 4b, and this will become a plus 1, plus 1. And to solve for c, I would multiply by 1/8 or divide by 8. So I'll just do this, and whatever I get, I'll multiply it by 1/8. And then substituting values in, I'm going to get 6 times a, that's negative 1/8, plus 4 times b, that's negative 3 over 32, plus 1 times 1/8. And that gives me, see, I'm going to reduce here. 4 goes into 32 8 times. And I'll write these using a common denominator of 8. So this first term is negative 6/8. I'm adding a negative 3/8. That's from this second term. And then 1 is the same as 8/8. And all of that's multiplied by 1/8. So let's see, negative 6 minus 3 is negative 9, plus 8 gives me a negative 1/8, times 1/8 will give me negative 1 over 64. That's the value for c. And then for my constant, I get 2b, there it is, 2b plus 2c minus 8d is equal to 0. And here I'm solving for d. I know the value for a, b, and c. And so let me bring that d term over. And I'll get 2b plus 2c is equal to 8d. And here I can divide by 8, which is the same as multiplying by 1/8. And so I'm going to get d is equal to 1/8 times 2b. Let's see, b is negative 3 over 32. If I multiply by 2, I'm going to get negative 6 over 32 plus 2c. Multiplying by 2 gives me negative 2 over 64. And I'm going to reduce this to 1 over 32 so that I can add negative 6 plus negative 1 gives me a negative 7 over 32, and 32 times 8 is 256. And that's my value for d. So if I put that together, I get my particular solution is a t to the third, that's negative 1/8, t to the third, plus bt squared minus 3 over 32, t squared, plus ct minus 1 over 64 times t, plus d minus 7 over 256. And then my general solution is going to be my complementary solution plus my particular solution, c1 e to the negative 4t plus c2 e to the 2t plus, actually, minus 1/8 t to the third minus 3 over 32 t squared minus 1 over 64 t minus 7 over 256. And notice this is my solution in terms of t. If I want to go back and get my solution in terms of x, then I need to use this substitution again. X, there we go. X is equal to e to the t. So x equals e to the t, or, again, taking the natural log of both sides, we'll get t is natural log of x. So notice that in this first term I have an e to the negative 4t. If I raise both sides here to the negative 4th power, let me write it over here, I'll get x to the negative 4th is e to the t raised to the negative 4th power. And that's the same as e to the negative 4t, which is what I have on my first term. So e to the negative 4t is the same as x to the negative 4th. On my second term, e to the 2t is the same as x squared. Here, t to the third, t in terms of x, you could write that as natural log of x. So this is natural log of x to the third, which you could also write as natural log. You could also write that as natural log x, natural log to the third of x. Minus 3 over 32. T squared could be written as natural log x squared or natural log squared x. So minus 1/64 t, which is the natural log of x, minus 7 over 256. This should be the solution. Now I know that when I check this against the answer from using the other form, they don't quite match up. And I suspect that I made a mistake solving for my u1 prime and my u2 prime, or doing the integration. But I did check this answer. And I believe that it is correct. Yeah, this answer I did check, and it did work out. I substituted it into the original equation, and it did make it true.